Aloha, my name is Robert from Papakahana, and welcome back to the Online Professional Development for the Canoe project. Today we'll be talking about Module 10 of 15. As always, we begin by logging onto our website, www.stemd2.com. And after we've logged in, we're going to go ahead and go on to Students, and let's build a canoe. Module 10 is in Unit 4, so we're going to go down to Unit 4. Now we're going to go ahead and click on Module 10. Here are the list of activities for Module 10, which is about transformations and similarity. The first activity that we'll be discussing is Canoe 10.1.1. This is the first activity that corresponds with Lesson 10.1 in the Go Math book. For this activity, we will be using an art technique to learn about the properties of dilations. To do this, we will need some graph paper and a ruler. When we need to make something big, expensive, or complicated, we sometimes first start off with a small model, also known as a prototype. Here we will follow Auntie Lani as she builds a house, or a hale, starting with this prototype. First, Auntie Lani puts this prototype on her mat, which represents a grid, just like your graph paper. Then Auntie Lani chooses some points on this prototype that she thinks are important. Here she chose 5 points to represent the 5 corners of this hale. Next, Auntie Lani will draw lines from the origin through the 5 points. So this line goes through this point, this line goes through this point, this line goes through this point, and the horizontal axis goes through the bottom 2 points. Next, Auntie Lani will move these 5 points down the lines that intersect them. She will pay close attention to how the dots line up vertically and horizontally. These 2 dots are the easiest dots to move because they are the rightmost dots. So they will be moved down the lines until they meet the right edge of the mat. This dot has the same vertical position as this one, so Auntie Lani will move it down the line until it's vertically aligned with this one. This dot has the same horizontal position as this one, so Auntie Lani will move it down the line until it is horizontally aligned with this one. The horizontal position of this dot is right in between these 4 dots, so Auntie Lani will move it down the line until it is right in between these 4 dots. Finally, after Auntie Lani has moved over all of the special points, she takes a look at the prototype and fills in the missing detail. In this activity, we meet 2 friends, Kekoa and Keoni. Kekoa and Keoni made a prototype of a sail, and they bring it to Auntie Lani, asking for her help in making it larger. So we have to first replicate this graph, and then use Auntie Lani's technique to enlarge the prototype. Then we have to calculate the scale factor of this dilation. As you may notice, we are dilating about the origin. However, the sail is not right against the origin. So what happens if it is? What happens if we move the sail over so it's closer to the origin? Here in this question, we ask the students to move the sail over and then dilate it again using Auntie Lani's technique. Then we ask the students to calculate the scale factor again. Does it make a difference where we put the prototype? Are the scale factors different? If so, why? Finally, we conclude this activity with an open-ended problem. If you could dilate any object, what would it be? And what would the scale factor be? For example, if you want an elephant that is the size of a puppy, you would want a scale factor of 0.1. That's it for this activity. Please go ahead and pause the video and give it a try. Let us know what you think. Welcome back. The next activity that we'll be looking at is Canoe 10.2.1. This is a very short activity, and it's about building a canoe and looking at blueprints. So over here is a canoe that we're building. Right now it's upside down because we are working on the hull, which is the top over here, which represents the bottom of the canoe. And over here is the blueprints for that canoe that we're building. By looking at these two pictures, we should be able to figure out the scale factors that allow us to dilate from here to here and dilate from here back to here. And that's precisely what this activity is asking for in the first three questions. It asks for the two scale factors and an algebraic expression. Finally, we end this activity with another open-ended question. We saw that canoe builders can use scale factors, but what other careers can use scale factors? This activity was a short one. Please go ahead and pause the video and take some time to review and reflect on it. Alright, welcome back. Let's go ahead on to our last activity, Canoe 10.C.1. This is the cumulative activity for Module 10. So here we are looking at an island that's up ahead. On the map, this island is at the coordinates 0, 6. If we are at the origin, then that means this island is 6 units away. However, in real life, this island is actually 3,000 feet away. So here is another map that shows the real distances in feet. In this activity, we will use this point and the previous point to figure out a scale factor. And then we're going to use that scale factor to figure out the positions of all these other islands. So we're going to be filling out this map and this table. That activity is pretty straightforward. So let's pause the video and take some time to review and reflect on it. Let us know how you can use this activity in your classroom. Well, that's it for Module 10. We'll see you again for Module 11.